Hi children, welcome back to our basic science class. Today let's start our 6th chapter. A little effort, lot of work. We use many simple machines to simplify human effort. To fix a screw, to open the lid of a box, to move a big stone. For all these, we seek the help of simple devices. Through this chapter, we can identify real-life situations in which simple machines are used. Let's start the class. Look children, did you see Paramuchetan husking coconuts? What are the different ways in which you husk coconut at home? Yes, using an axe, using a chopper, using a coconut husking device, etc. Which of these methods is most commonly used? Yes, you are right. Coconut husking device is the most commonly using method to husk coconuts. Do you know why? Yes, by the use of this, we can reduce the human effort and less time is needed to husk number of coconuts. Such devices that make any work easier are known as simple machines. You see a knife, a scissors or a screwdriver in your home. If someone says that all these things are machines, will you believe it? Perhaps you will not. But this is true. They are also machines. A device that makes our work easier, faster and more convenient is a machine. Screwdriver, hammer, bottle opener, wheelbarrow, plier, knife, spanner, etc. are simple machines. Simple machines have a few parts only and are easy to use. Now, look at the pictures of some simple machines. Tabulate in your science diary the task made easier by these devices. You may tabulate it like this. Simple machines, task made easy. Hammer, to fix and plug nail. Spanner, used to tighten and loosen bolts. Screwdriver, used to tighten and loosen nuts. Forceps, to pick objects. Nutcracker, to cut areca nuts. Knife, to cut things. Lemon squeezer, to squeeze the juice of lemon. Bottle opener, to open bottle's lid. Scissors, to cut objects. Pulley, to lift weights. Wheelbarrow, transfer objects from one place to another. Now, observe the children playing on seesaw. On the first seesaw, the bigger boy has easily lifted up the small child. You see the two children balancing each other on the second seesaw. Don't you see that the small child has easily lifted up the bigger boy on the third seesaw? We can find out why this happens observing the position of the child and the hinge on which the seesaw turns. In the first seesaw, the bigger boy is sit near to the hinge on which the seesaw turns, but the smaller boy sits away from the hinge. In the second seesaw, two children sit at equal distance from the hinge on which the seesaw turns. In the third case, the smaller boy is sit away from the hinge on which the seesaw turns, but the bigger boy sit near to the hinge. This is why the small boy can lift up the bigger boy. Okay? We use strong rods to lift heavy loads and thus reduce our effort. This is possible because the rod is free to move about a fixed point. So, levers are rigid rods that are free to turn about a fixed point. Levers are simple machines because they make our work easier. Next heading, let's make a seesaw. Can you lift 5 marbles using 1 marble? Let's do this activity. Materials required: a long ruler, 2 empty matchboxes, 6 marbles, a pencil and a double-sided gum tape. Make a seesaw as shown in the figure. Place the matchbox each on either side. Put a marble in one matchbox and 5 marbles in the other. Slide the ruler over the pencil as required to maintain balance. Slide the ruler again to a position so as to lift 5 marbles with 1 marble. Here the ruler acts as a lever so that a greater weight can be lifted using a smaller weight. Now, see the picture of a man lifting a big piece of rock with the help of a crowbar. Here, the crowbar acts as a lever. It is because the crowbar turns about a small stone kept below it that the big stone gets lifted. The point about which a lever turns is called the fulcrum. So once again, what is fulcrum? The point about which a lever turns is called the fulcrum. Then where do we apply force? Yes, here. The force we apply is called the effort. We represent it as E. So, what is effort? The force that we apply on the lever at a fixed point is known as effort. Now, where did we place the weight or load to be lifted by force? Yes, it is here. The resistive force that is overcome by the effort is called resistance. We represent it as R. Once again, what is resistance? The resistive force that is overcome by the effort is called resistance. Now, let's recall the main points that we have learned today as: first point, simple machines. The devices that make any work easier are known as simple machines. Example, hammer, spanner, screwdriver, etc. Second point, levers. Levers are rigid rods that are free to turn about a fixed point. Third point, fulcrum. The point about which a lever turns is called the fulcrum. Fourth point, effort. The force that we apply on the lever at a fixed point is known as effort. Last point, resistance. The resistive force that is overcome by the effort is called resistance. Okay children, hope you all understood everything. Study well. See you in the next class. Thank you.